So next up, we have a few lightning talks back to back. First one is about automating Kubernetes deployments in air-gapped environments from Chad Crowell. Chad is a Kubernetes SME at Raft. He is a CNCF ambassador and author of Acing the CKA from Many, I believe. So he's also doing the shirt. So definitely excited to hear from Chad. Jared? Thank you.
Everyone's all charged up for lunch. Good. All right, so my name is Chad Cole. I'm a Kubernetes SME at Raft. Raft, we have the big billboard back there. I want to talk to you about automating Kubernetes deployments in air-gapped environments. So I want to start with the NIST definition of air-gap. So an air-gap is an interface between two systems not connected physically, and any logical connection is not automated. So air-gapped environments have no layer one, no physical connection to any infrastructure that's connected to the internet. So they're like islands, no connectivity to the outside world, nothing but air, hence air-gap, right? There's a lot of good reason to air-gap your environments. The physical barrier allows for more control, prevents intrusion, and more confidentiality. And it's not just government. Air-gapped environments are used in the stock market, for nuclear power plants, and transaction systems for retail. And so in the agenda today, in this short remaining 4 minutes, we'll talk about the problems that are presented when delivering software over the air gap, and then we'll go into automating deployments, so talking about eliminating any possible human error, and following the practice of cattle, not pets. And then we'll talk about some of the tools that we use at Raft to help with that process. So we know that air-gapped networks have the advantage of protection from external threats and greater control over the security boundary. But the downside is that we have difficulties patching our vulnerabilities in a timely manner. We don't have access to the control plane endpoints like we normally do. And also deploying software historically has been pretty piecemeal, problematic and kind of clunky. Mostly because we can't deploy directly from staging to prod. So patching up all the dependencies, binaries, libraries, and kind of sneaker netting it over or doing the file transfer over the air gap is pretty difficult. And it's hard to replicate your dev environment exactly, right? You can't exactly go directly from staging to prod like we normally do in our pipelines. So, plus you have to get it right the first time. In the air gap, there's no turning back. You can't make any changes in the air gap once you're there. You're kind of stuck. And those are my bullet points. So patching vulnerabilities, access to endpoints, and continuous delivery. All pretty problematic. We have made some progress, so using Kubernetes installed as a single binary, like in RKE2 or K3S, which reduces the footprint significantly, but also helps with the packaging up of our software with the platform. Kubernetes also helps with this as we have a consistent environment between dev and prod, or staging and prod. And as we know as DevOps professionals, this means that our pipelines, or as close as we can get to our pipelines in an air-gap environment, are more reliable and secure. So we can skip some of the pre-flight checks as the platform, meaning the underlying Kubernetes cluster is consistent no matter where you put it, right? And the fact that we're using containers versus VMs reduces the footprint even more and reduces the start time too. And in some cases, we can get the total size down to 5 gigs, which is pretty good. So now we have a consistent environment, a consistent platform. When we talk about delivering the applications on top of Kubernetes, we start to get into tools that can help us automate the deployment of those applications, ensuring that they follow the DevSecOps reference design and take the guesswork out of artifacts, both the container images and the SBOMs that get generated. This creates consistency so you can deploy something the same way each time, and you know it's vetted for air-gap. So I mentioned RKE2, which is a CNCF certified Kubernetes distribution. We also use Kyverno for policy enforcement so that we deploy only STIG images. We use NuVector for detecting vulnerabilities, GitLab for source control, Istio for service mesh, Kiali for observability, Sift for generating SBOMs, Jenkins for CI/CD pipelines, Scopio for copying those images from registry to registry, Flex for GitOps, Helm for packaging up and templatizing our application manifest, and all those things together packaged up in something called Big Bang. If you've never heard of Big Bang, it's an open source tool from Platform One for deploying all these things that we call our software factory. And at the end of the day, we have a solid foundation for our apps to run in the cloud-native way, but not in the cloud. And this all seems like a lot, and you may be thinking, oh my gosh, I gotta deploy all this to the air gap. And it's really not. I think you'll notice that a lot of these tools use the existing Kubernetes infrastructure or Kubernetes API, and it becomes a very small package at the end of the day. So again, my name is Chad Kroll. I'm a CNCF ambassador, author, and Kubernetes me and Raft. Come talk to me. I'll be here the next couple days at DevOps Days, and I'm also organizing another Kubernetes Community Days called KCD Texas, so I'd love to talk to you about that. And also, I have a book called Acing the Certified Kubernetes Administrator Exam. I'd love for you to pick that up, or at least let's talk about it and get you passing that certification exam. And so, because this is only 5 minutes, I'm getting cut off. So scan this QR code, and I'll give you the slides and notes from this talk, or you can just go to scks.com/automate. Thank you very much.